This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber. Before we get started, an important note. Our listener, Gabriel Krummenacher from Zurich, asked us to point out a survey he is currently conducting with Eidgenössische Technical University of Zurich. Topic: exploring the state of machine learning in enterprises. So please check out the show notes and participate. We thank you on behalf of Gabriel. The results will be available here in the podcast after our summer break. So, and now to the episodes. My guests are Helmut Prieschenk, CEO of WITRON. WITRON automates distribution centers of Aldi, EDEKA, Walmart, Coop, Boots, Leclerc, Migros, and many other retailers in the USA, Canada, Europe, and of course, also Australia. My second guest is Franziskos Kyriakopoulos from Sevenlytics in Linz from Austria. He and his team do demand forecasting also for retailers. And that's why the two guys are a good match. So enjoy listening. Helmut Prieschenk, welcome.
Good morning.
And we have invited Franziskos Kyriakopoulos from Linz. Welcome.
Good morning. Thanks for having me.
Yes, you're welcome. Today we want to talk about data, demand forecasting, therefore also machine learning, AI. But before we start, let's talk about the elephant in the room. Mr. Prieschenk, have you ever used ChatGPT yet?
Yeah, we're listening to this. We're verifying what is going on, no question. We take this, I want to say, serious, but we are not going crazy about it.
Okay. Do you use it for writing love letters or for coding? What was the idea?
I'm practicing grandpa, so the love letter time was some time ago. No, we are just interested how the development is going and what people are doing. We want to focus on the business, on our customers, on what the professionals are doing with this, and we are not so interested in what is happening in the soap opera.
Okay. Large language models. ChatGPT is a large language model. What can they change also for companies like WITRON?
Yeah, well, these models are trained to predict the next token in a sequence, and this can be a word, but it can also be a number or something else that happens after time. And what's interesting for us to see is how good does this work on structured data also, which are omnipresent in the logistics field, like movement data and stuff like that. And obviously, whenever text, like in marketing or in customer communication, is important, then one also can test if these models bring in added value.
Do you have an idea where to use it in the warehouse?
Yes, well, what we also saw recently is a publication where you have this movement data of articles coming in and out and going from A to B, and GPT or transformer models, not ChatGPT, but a specific transformer models were used to simulate the next movements and see how realistic these are. This is a specific case. We want to see if we integrate.
How successful was this?
It's a paper, so it's not real world tested. You will have, like in any research paper, a table with metrics, and the authors claim that this is very good, but you have to test it in the real world to see if it's very good. And since we have a lot of data from various environments and companies, we can test it, and this is what we are finding out currently.
You were in Vienna a week ago or 2 weeks ago, and there's a retail congress going on, and there's a Spar and Biller and Intersport and all the brands. How these companies react when you talk about demand forecasting, AI, machine learning? Are they amazed by the technology, or what is their feeling about this technology?
Well, it's gotten very much better in the last years, also due to the ChatGPT mania. But the main topic
ChatGPT mania is very good. Yeah.
The main topic of the conference was artificial intelligence in retail. Yes, so there was a lot of talk about. So they've heard it now. It was different 7 years ago when we started. Then it wasn't so present. Not everyone is able to extract the value, but many of them are trying to make the first steps now. So it's getting, we see progress.
Do you see the discussions also? Do you hear the discussions with your customers?
Absolutely. But I think we need to be a little bit more realistic in terms of what is the customer focus. And the customer focus is first and foremost, he want to satisfy a client. That means SKUs or articles in the shelf or at the house store. Priority number 2, I want to say, is a business case. Priority number 3, and this is just a sequence, is maybe sustainability. So these are the things where our customers are focused on. And now the question is, what can such a tool or a technology or a mania contribute to fulfill their targets better?
How difficult is it to find a business use case for the technology?
In retail and logistics, there are enough. Demand forecasting is the king of the business cases, because just imagine you would predict what will happen very accurately, then you can act on it. But there is also in marketing, in pricing, so there is a whole chain of use cases. I once saw a McKinsey study who said there are like 30, but many of them are, of course, moonshots also, but it's not very hard to actually find that out. They're much more realistic also than the ChatGPT use case, where I just put a text in, I get a text out.
But how difficult is it to convince these retailers to use this technology and to solve a business case?
Yeah, this is something different, of course, because sales cycles are long in this area. Typically, in the past, it was so that retail needs more convincing than industry, for example, or manufacturing, because you have more technical people there, yes, and also more in retail than in logistics. But now more and more,
so industrial sector was easier than retail, and retail was easier than
it's like industry, logistics, retail in the same direction as the supply chain goes. You have also this technology adoption, yes, because the manufacturing guys use it for the processes, for example, yes. Yeah, this is it. And then you have to, now the retailers build up teams of data scientists, for example. So they have understood it, they want to do it now, and the decision is actually not should we do or should we not, but it's more a make or buy decision that you are taking, and at which point should we invest more money in it.
What is WITRON's role in this game? Is it a partner, or are you a technology leader? What is your role in this AI machine learning demand forecasting game?
Well, for our customers, it's not so much an AI game. It's more a supply chain end-to-end responsibility, what they see. And when we see the end-to-end big picture from the supplier, transport, DC, etc., then the question for our customers is, as it was mentioned before, what value can be contributed with information related to the future? This is what we're talking here. In that moment where you have good information about what will happen, then you can use this information for different purposes. And now the question is, and this is then the tricky part and the exciting part at the same time, are you optimizing revenue? Are you optimizing profit? Are you optimizing sustainability? Are you optimizing lead time, etc., etc., etc.? So you have different opportunities, but the key is always when you can deliver information about what will happen tomorrow or the day after.
What is your optimization use case you present to the retailers? Optimize revenue, optimize forecasting?
It depends also on the customer's wishes, because it's completely...
But do they have wishes, really? Or they want to have an input from you?
Both. Some of them have wishes because they are very aware...
Are these wishes realistic?
Yeah, this is just, I have a business problem, I want to solve it. This is for us the sweet spot. So if he knows I'm getting too much out of stock, or we don't have the correct products, or customer communication doesn't work, so there are a lot of issues which can be very clearly formalized. But in some cases also they say, okay, you guys know how your way with data and machine learning, maybe you can surprise us with something also. So it's like a conversation. It's on this level. Actually, if we can say, okay, this is a very concrete problem, I want to make a very accurate sales forecast and then also a demand forecast, so also have the missing sales in it, then it's from a machine learning perspective clearly formulated, and I need clean data, and then I can run this through. Yes, but still, even if this works pretty out, we are not at the realization yet, because if I make the forecast, these products need to come there, yes, and then there are events which could change that. So these complexities needs to be thought of, yeah, and in some cases I have this multi-objective optimization, which where I only can get to the Pareto frontier if we want to talk it mathematically, but this is trickier than only having one single objective and I'm going straight through.
Mm-hmm. Can you explain this, your demand forecasting model for a little bit machine learning for beginners? What kind of data sets you use, how you use it, where is it situated? Is it in the warehouse or is it at the retailer's office?
Yeah, let's play the game that we want to have a sales forecast for supermarket stores, for example. Then the first thing we need is the sales data. Yeah. So in principle, what the customer buys and when it was bought and how much and to which.
It's easy.
That's in most cases easy. We've seen cases where it's not so.
Why is this not so easy for some retailers?
Smaller ones have their difficulties getting that out of the IT systems, and then you need to talk to 5 other people. But of course, the large ones have this structured, and you can make a query to the data warehouse, and it comes out. Yes, but it's always interesting. Then obviously you want the stock, because you want to know, okay, so much is sold and so much is there.
That's your part.
That's correct.
So you need the stock data, and there the data quality issues become
hopefully good data.
Absolutely, yes.
Always. This is the baseline, yes? Then if you have customer data, which not every supermarket has, because not everyone has a customer card, you want this also because then you can understand, the model can integrate the information, how are people buying. It's different if some chains say, no, we are anonymous, everyone buys anonymous. And then come the marketing and exogenous and event and time and what day is it and vacations and all of this stuff. Also the geographical data, where is the supermarket located? Is it in the city? Is it outside in some mall or something like that? Yes. And obviously you want to have some event data, like what's happening right now. Do we have a football game? So beer will go up and stuff like that. This is always an influence. Well, long story short, you put all this data together. You have to do a lot of wrangling to combine them and transform them to numbers, because machine learning models only take numbers as input. And then you play it through, and you start with very easy models, because you will compare the performance to something that everyone could do. So in principle, the first question I ask, can I do it better than in Excel, moving things around? Yes, because if you can't do that, then obviously no one is going to pay you money for your awesome AI. And then you iterate over degrees of varying complexity in the model space, in the feature space, and so on, until you reach a limit where the model is either so good that it gets accepted by the customer, or you see that you cannot optimize anymore in the metric.
How accurate is your model?
Yeah. I don't want to give the stupid answer. It depends, but it depends. And it's, for example, in supermarket where you have periodic signals, because people buy milk and bread in a somehow regular fashion, right? Yes? There you have a high signal to noise component. So here you achieve very, very high levels of production, or of predictive accuracy, or very small errors of error, below 1%, for example, yes? But in other cases, like in fashion retail, where you have only seasonal articles which come and go and are highly dependent on what did some influencer on Instagram put on in the Oscar nights, and which you cannot predict 1 year in advance, there you have higher variability. And that's why it's important to follow this procedure that I said, because if I can ask, what's your error now? How off are you now? And they say like 40, 50%, and then you bring that down to 30 or 20, then you have added some value, right?
Yes, it sounds good.
It is good, and now we have to match this with reality.
Yeah. How do we match it?
Because this is then the key to use all this information and this intelligence for the reality of a food retailer. And from my point of view,
it's always reality check with Mr. Prieschenk.
Yeah, I try, and sometimes it works. The reality is that these companies are very open to things where they can improve their process, and they are aware that they did an outstanding job the last centuries. When we think about with which tools they're working, data lakes is something we're talking today. Go back 20 years. 20 years ago, we didn't have an iPhone. So how did we survive, right? How did we came to work without an iPhone? Unbelievable. So they worked with their tools, and they are doing an outstanding job from my point of view, whether it's Europe or North America or Australia, in delivering perishable goods with a limited shelf life out of a huge range of products every day, through the week, through the season, through the pandemic, etc., etc. So I think we can be very proud with these companies, what they are doing, also from a sustainability standpoint. Now, the question is, how can we use these opportunities, what were mentioned before, in their reality? Because they are living in a process. They have infrastructure, they have IT systems, they exist somehow in an environment. And I think the key is now to bring these things together to create value for the client and for the business report.
Model deployment, the big topic.
Yeah, model deployment is one thing, but model deployment sounds quite technical, and this is not, I would say, the big question mark. The big question mark, which needs to be answered positive, is if the business person working as a supply chain manager or store manager or whoever is in charge of this logistics process or goods flow is happy with what information she or he gets out of this model. And if this person says, okay, I have now less boring work to do, and I'm more confident that we have good products that we are actually selling to our customers on our shelves, that's the success at the end of them. And of course, you can, in many cases, measure this success with some KPI, and then you can compare in units of euros. Yes, it's not always so easy, but it actually can happen, and that's a high criterion. Yeah, of course, you have to solve the technical issues and the deployment.
With
APIs, containers, cloud, or on premises if it's wished, integration to the ERP, and all of this technical stuff have to be solved. But this is not, how do you say, rocket science.
But
right?
This is difficult. This is really, really difficult.
It can fail. It has failed often in big companies costing up to 100 millions of euros. But from my perspective, as a data science and AI company, it's not the key question, because as stupid as it sounds, what the end person needs is a list of movements that should be performed. This can be given per mail. We have actually, maybe a small anecdote, in fashion retail, we have sent lists because it was not technically possible to integrate to the ERP. We have sent lists with recommendations of prices per email, and this were then, after being viewed manually, the prices were written on etiquettes. Nothing was digital. Yeah, so you can go on the deployment on this edge if you need to. Yeah, but it's the quality of information that makes the success.
I have two more questions about the robustness of the model, because we had the pandemic, COVID. How robust is your model on situations like a pandemic?
Yeah, your model maybe is a simplification, because it's not one model, right? It's like hundreds of them, and it's the ensemble of the best ones. But let's call it the solution, or the model is the thing that outputs, but it's multiple machine learning models. Obviously, if I would say that in December 19 we would have predicted what happened in March 20 in the logistics area, I would be a liar, and this we did not, and as far as I know, nobody did. Yes, some guy in the States had a dashboard with the data, but he didn't use it for logistics prediction. So the question is, since you cannot predict everything and every shock that's coming, how fast can you adapt to it? And what we saw in the logistics of supermarkets for frozen foods, which went high up, is in the first weeks it missed it, but very soon it had gotten the level and was on the past accuracy level again. Yes, because a good machine learning model needs also to be able to treat some outliers. Yes, not everyone, but adapt to them.
When I think about your customers and the women and men in the shop who are responsible to order new stuff, do you think they believe in such a recommendation of a model?
the question is first and foremost, who is ordering? Is it the responsible person in the store, or is it a software, or is it the headquarter, or is it a push, or is it a pull? So I think the reality is a little bit more complex, but I think the point is you have to prove that you're delivering a better result. Trust is nice. Trust is certainly important in the long term. But what really counts is you have to deliver better results. This is the most convincing situation. And I think in that moment where we taking out the confusion and the complexity of this conversation, this is the best value we can create, because if you ask people on the shop floor and giving them 3 buzzwords and 5 optimization targets, it's more confusing than you creating really value. In that moment where we really see the big picture, and the big picture is in principle simple. You have a client demand, you have a balance sheet, you have the nature, so sustainability, and the question is, in the supply chain end to end, because the supply chain is teamwork, right? It's not only warehouse, it's not only store, it's teamwork. Where do I need to optimize and adjust to do a better job for balance sheet or? Then I can really use this information about what is happening tomorrow in a great way. But I really need to be precise and reduce complexity.
How important is this explainability and reduce complexity?
Very important, I would say.
How do you handle it?
Yes, we are getting asked all the time since we began and made demand forecast from our customers, why does the model predict this amount for this article? Yes, and this is of course mentally coupled with the experience of the person asking, because okay, this is a shoe, this is milk, or this is bread, and this is how this works, and so on. There is a mental information image of how these things should sell or be transported, and if the model gives something else out, this will be challenged. Yes, and you need to answer these questions, because if you don't, you will not have acceptance, and then your model will not find its way to reality. Right. So this is the one. How do you do it? There is a ton of statistical methods, but in principle, it's feature importance is the first step, and detailed inspection is the second one. What do I mean by feature importance? Features are all the inputs in the model, which can be the past sales or the marketing action or the current date or the price. Right? And you can ask the trained model, if it's good enough and you have validated that, which was the most important feature for your prediction, what was the second most important, and so on. You can get weights of that, yes? So this is a standard method. But then, of course, you need to ask the question, well, if price is important, which is obviously, right? Or price change to be more consistent. How does this work, right? And you have, obviously, from economics, but also common knowledge, some answers which say if price go down, sales go up, right? But in some cases, and we have seen this because we have handled a lot of data, sometimes price go up, sales go up. And this is counterintuitive. People have to learn that. Yeah, it's not the majority, obviously, because else economics don't work. But there is a small percent of articles and places in time where this works. And this information needs to be made transparent to the end user and explained to the end user. Because if I confront you with something like this, you say, oh, what is this kind of stupidity? Yeah, that doesn't work. And then you say, yes, it does. Here is the proof, because this happened actually, right? And at this level of transparency and explainability, we are. What we can, maybe, let me add this one. A machine learning model cannot explain something that happens in the real world if it has not been fed the information. I cannot have, if some customer calls and says, I don't want to work anymore with you, and you don't have this information, you will miss that, right? Obviously.
Who do you see in the lead for this technology, demand forecasting AI? The retailers, WITRON, the stores, the manufacturers? Who is in the lead?
I think we have responsibilities everywhere. One responsibility is with us and the system integrator to create the environment that technology is available and to integrate such technology. There are the professionals, like here on the table, who are deep in this technology with long years.
But do you bring them with you?
This is not the question whether we bring them. The question is the problem on the customer side ripe enough to be addressed? Is the pain point big enough? And then whether we bring the colleagues or whether the colleagues are earlier on the customer front or the customer is already in the... this is, for me, this is just a sequence of time. The question is, we need to see that there is a possibility to create customer value with technology. And this is the key part where we need to be down to earth, to bring these together through all the buzzwords to understand what is happening. Because again, when we're talking, for example, about you increasing a price and maybe the sales goes up or down. When you're asking a store manager maybe is adding, well, depending on where I position the SKU in the store, on the top or on the down of a shelf, this is an influencing factor of sales. So these are the nitty-gritties of this environment, and therefore I think we need to be humble that there are so many factors which are important in this whole equation that we should include everything in the conversation.
How difficult is it to calculate this use case that it's in another position in the shelf for the model or for the tool?
It's pretty easy if it's been considered in the beginning, if someone thought about it, which is, of course, if you know about retail and stores, it's obvious, but not obvious for a data scientist who has studied mathematics, yes. And the second thing is, are the data available? So do you have to every SKU 3D or even 2D, let's call it 2D, positioning in the store, yes? And also some...
that sounds... Wow. 2D pictures.
No, but works. That is realistic. That is absolutely realistic that they have their store planograms. Yeah. They know on which level, in which shelf. We had a customer, or we have a customer. They have the philosophy: 2 articles from one SKU. 1 for show and 1 to go. That means when one customer is buying this whatever shampoo, then you have 1 rest, and then you are better hurry up because then you need another 1 to go, 1 for show. So they are working very, very precise on this data, and they are available.
So data availability is no problem.
That is not a problem. The question is, you need really the right data, and you need the data end to end. You cannot focus only on stores. The store is the key. 95% of the volume of a food retailer is in the store. So this is the key. But you have data in the transport, you have data on a producer side. The producer is managing production slots, for example, for chocolate or whatsoever. So he is also working in his ecosystem, and he is having exactly the same conversation what we have here about data. Now, the question is how do you share data between the supplier, the producer, and the food retailer, or all suppliers with all food retailers, etc., etc. So this is the next interesting factor in this whole conversation. But we need to make sure that when we're talking about a SKU or an inventory, you have this really from the field, from the orange field, where the oranges are coming, to the basket of the client. And if you want to win this thing, you have to go end to end.
I interrupt you about the shelf. Can you go on with a 2D model and what you mentioned there?
Well, in the best case, there are actually really good data because we also know of technologies where the shelf knows if something has picked up. So this is technologically feasible. There are companies who make this with specific sensors. So in principle, theoretically, the supermarket knows not only which products are in which shelf and which quantity, but also knows how do people move through that. You can do that perfectly GDPR conformably and have a tracking and have hotspots and okay, the people stand 5 minutes longer in this shelf at this site, and they're less. And in principle, you can integrate that. But in life is dirty. In 80% of the cases, you only have 20% of this data. So in principle, what you always get.
So it's a problem, data availability in these use cases.
Well, you can't always get the perfect sample from everyone. Let's put it like this. But you can get it from someone, and the more rich or technologically advanced the retailers have, the better data they may have, yes, in the best case. But also there are big retailers who are missing basic structural data, like the stock per day in each store. You may be surprised, but they exist, and they are not some small ones. There are also some big ones, yes. Others are pretty competent. So in our job, the first thing to do is to check data quality, because if data quality, this is all garbage in, garbage out, right? If this is not fine, it will not work good.
Do you think that tools like these tools we discussed, demand forecasting, are the future for retail business?
A part of it. I think the future for retail business is a mix of different things, whether it's physical, whether it's.
But do you invest in such tools?
We are investing in the integration and the interfaces. This was mentioned before, because the question is always, what can you as partner integrate and contribute as value to the game, right? And when we are contributing machines, when we are contributing complete infrastructures for a warehouse, then the question is, how can we integrate to transport management systems, to forecast systems, etc., etc., etc.
But you wait for it.
No, we are integrating these things already, because the question is not whether WITRON is waiting or moving. The question is whether the technology is there and ripe, and you can use it really in real life. This is the key. And in that moment where we're talking about an idea or a revolution, which never happened, as we all know, with a fourth industrial revolution, which was announced and never happened. So we need to be down to earth. Like, is it substance in this whole thing? And then automatically this will become a reality in the world of when we are talking about food retail. In other industries, probably you have completely other rhythms where we are not so familiar with, to be honest with you. But I think you are much deeper in these things where you have then other profiles. It's maybe not the week and Christmas and whatever Easter. Maybe it's then Black Friday or Black whatever week, or I don't know. And then you have other craziness to handle.
At the beginning, we talk about this large language model and the future of AI a bit. Will we see a large warehouse model in the future for a WITRON warehouse or for a WITRON supply chain, or what is the idea?
Well, this vision exists since a long time. So you have the autonomous agent everywhere, and a lot of research has been done. I have not seen a realization yet. I see active research papers which claim to train the agent that can do a lot of things. But there is always this reality check, right? Writing a paper and making a simulation is something different than bringing it here. And what's missing is how do people work, how do processes work, how do physics work, what happens if you transport from A to B, how do you deal with these gaps that exists and unprecedented events and volatility and all of that stuff that make life messy and interesting. But the vision has been always there. This is the principle of artificial intelligence is that we have agents or robots doing our work for us, and then we can lay back
on the sunroof.
This will never come. Yeah, well, it's like a Platonic utopia, you will never reach the exact thing, because we want to do something, we want, if you have fun at work, you like to work. But it's interesting for me is more this marriage between the machine learning and the complexity, because it is very complex. End-to-end supply chain is a highly complex system. Yes, we know that. And there is a lot of uncertainty. And how can you apply good forecasts or recommendation engines or pricing engines or even non-typical machine learning stuff like route optimization or stuff like that? How can you apply this at different aspects of this network, because it's not a supply chain, it's a supply network, to make more money, to deliver value, to have happy customers? So that's the big question.
What about the large warehouse model by WITRON?
I want to say supply chain model and not warehouse model, because
by WITRON.
Absolutely. Absolutely. And this is really a topic, I don't want to beat this to death here, but it's about the end-to-end visibility and the end-to-end optimization, because it doesn't make sense to optimize a silo, to optimize a transport and other guys are losing. So it really needs to be end-to-end. And then you want to make a wise decision, what you optimize, in which part of the year. So this is something I think which is really relevant when you see the whole model. And I think this will come more and more. Today, we are producing automatically pallets. Since the invention of Mr. Winkler's COM machine, we don't lift anymore these tons. And the same thing will happen, I think, with the production of processes or data or forecasts or. And I'm pretty sure, the expression begin with the end in mind, right? I'm pretty sure 10 years from now, people will not talk about it anymore, because everybody will have the forecast and everybody will sit somehow in the driver's seat. And this is the good thing, that with all the machines, with all the information systems, and with all the artificial intelligence, at the end of the day, there will be people who sitting there and making decisions delivered based on informations which are delivered from machines, computers, data, etc., etc. This is the good news, I think.
Thank you very much.
You're very welcome.
Thank you very much.